Okay. Hello, everybody. Who we have? We have
How Quinn?
Armando.
Hi Quinn.
Hey, Emilio. How are you?
Very well. And you?
Great. Great. Thanks for joining me today.
It's a pleasure.
Right. I know you just came out of class, so we'll get you some more learning today.
Yes, today I've got a problem due to my PC. It decided to disconnect it from the lesson.
Of
I
course.
sent an email to you and Dave for apologize for this inconvenience.
Yeah, no problem. Yeah, technology, right? That'll get you sometimes.
Okay.
Okay. Yeah, thanks for joining, like I said. So, I'll just kind of get into it. We'll wait just a few minutes, let some other people trickle in, and we have Karen Ann joining us to help answer some questions and help you along the webinar here. So, we'll start getting into it. So, welcome to our December Customer Connect webinar, and thank you for joining us today. And today is actually going to be our last webinar of the year. So, thanks for making it out. And if you were able to make it to any other sessions, that's great as well. As always, today we're going to have a featured demo covering a Simac feature. Then we're going to open it up some questions and comments, and there were a couple questions we had on the registration form we'll go over. And then as always, as we look at this Simac feature, I make sure to just kind of point out how to navigate the platform and some little features around to help everybody be familiar with using the Linux platform. So please feel free to ask questions anytime, related or unrelated to the demonstration, and we're happy to answer them. Feel free to either raise your hand and interrupt me, or you can put it in the chat, and Karen Ann will kind of monitor that and make sure we're on top of our questions. And yeah, Karen Ann, if you could just admit people as they come in, we're just having a couple people trickle in. And and so then today our included demo, we're going to be covering measuring relative output factors and how we can do that on Simac. And I'm going to show you a couple different ways. And then we're going to investigate a couple different field size setups and a couple different ROFs. So we'll get into it in a minute here. And just as a quick reminder, most of the people invited to the webinar, you do have unlimited, Simac access, which means that you can use it, anytime from any device, as many times you like. If you don't have that full access, oops, sorry about that. Anybody can get a free account and use Simac 5 times a day. And just to show you what that looks like um, on the website, right? So we log in, we make sure we're logged in, and then Simac can be found up here. You're welcome to use Simac 1, that's our first version. Simac 2 is our newest version. We're coming out with Simac 3 in the new year, but Simac 2, so you can come in here and you can click this Run Simulator button 5 times a day, or if you have unlimited access, unlimited times. And what's really great is any beam that you create, so you can really match your machine, you can create your beams, run them with different field sizes, different flattening filters, different steering coils, all this great stuff to investigate dose and your profiles. And we can save these beams, you can save them however you'd like. So if it was December 4th, I can save this, and then oh, December 4th, right there. There's my save state. And then I can call that back. So, if you want to teach and demonstrate or just practice and learn or investigate beams or research, Simac can really help you out. So that's why we created this webinar, just to, get you guys more familiar with what's available on the platform and then how to kind of get into that. So, and if you're looking for more uh, help on your own using Simac, I recommend our student resource portal, which is you click your username, and we go to the student resource portal. And this has some great manuals and guides. We have a Simac guide, a TC51 guide, and a platform guide, as well as these are our procedure exercises. We have these great 13 procedure exercises that take you through using Simac. So it really gets you good experience on some procedures like, elective beam energy, variant beam energy, flattening filters, as well as really helps you understand how to use Simac, because we do understand it's a bit complicated. So we do have these available to everybody. These are available to everybody, so feel free to go and check those out. Okay, so that's my little spiel on just a reminder where Simac is. So let's get into the demo a little bit. And so like I said, Today we're going to be looking at, ROFs or relative output factors. And I'll start kind of by just going over why we care about this and why we're going to cover it and why we think at Simac it's important and useful that we can look at this on Simac. And so, relative output factors or ROFs describe how much radiation a Linac delivers for different field sizes or different field configurations relative to a reference field, which is typically a 10 by 10 field at 10 centimeters. I'm sure, we're somewhat familiar with this. And at their core, they are the core parameters in commissioning, patient safety QA, and dose calculation. They directly affect treatment planning accuracy, calculating monitor units, and machine consistency and long-term stability. So they're very important to the long-term stability of our machines and for accurate, treatment planning. So, but it's not enough to just know how to calculate them. As we get further into our training in the modern training, we don't have a lot of time in machines. We don't have a lot of time to really get into the physics and understanding why we're calculating or how we're calculating these things. We just calculate them. But understanding the physics behind ROF actually helps physicists make better measurements, choose the right detectors, catch machine issues early, and build, overall safer and more accurate treatment environment. And it's very important, in the understanding ROS could be a little complicated. We can help diminish common learning mistakes like assuming linear ROF changes and understanding things like the jaw exchange effect, right? Before ROS were just very, very difficult to teach because they take so long to set up, and then you have to be changing your flattening filters and changing your field size and your jaws all the time. I shouldn't say your flattening filters, more your jaws all the time. It just took a long time to get through that setup, and then there was very easy to make mistakes as well. So now on Simac, we allow you to show this simply, run multiple beams in minutes, change your jaws instantly, and then also, right, we can go to the extreme, never seen in the clinic scenarios that highlight the theory more dramatically without breaking a real machine, right? And it really allows our students to get to see it with their hands on it to really understand these phenomena or why we're doing these things and how understanding them more is going to make a more effective team. Okay, so that's my spiel on why they're important. So we'll move on from that, and let's go into Simac and let's calculate them and let's see how we can do it in Simac. So I'm gonna do it at a 10 centimeter depth for clinical accuracy and to just to see our scatter effects a little bit more pronounced. I know some people do their ROFs kind of at D max or 10 centimeters, so I'm gonna do it at a 10 centimeter depth. And back to our slide here. This is our formula, right? Our relative output factor is an output at a field size, and we're going to do our 10 depth divided by our output at our 10 by 10 field at our 10 depth. So we have to get our reference dose, and then we can get any output at any field configuration, and we can calculate our ROFs. And so I'm going to show you how to do it two ways in Simac. I'm going to do it once on our TG51 simulator, which is really using like the console and the water tank, which is a lot more, lifelike or clinic-like. And then I'll do it on our full Simac simulator, which will be a little bit more involved and calculated method of doing it. But both will get us the same results. So to head to our TG51 simulator, we go to Simac and we jump to our TG51 simulator. So we can see our console interface, kind of blank because we haven't selected machine yet. I'm just going to do it on variant machines. No reason why. We could do it on Electa, and I'm just going to do it in the 6MV. Again, no particular reason why. You could choose any energy in this as well. So now we kind of selected our machine. Let's go. We'll go set up our water tanks. So first, we're gonna set up our SSD, and so like I'll just do an SSD of 90, and so you can see here we can really fine tune that in our depth, and then we can fine tune the depth of our water of our ion chamber to make sure we're at that 10 depth, and then I'll just make sure that it's centered on that x-axis as well. Oh, and then I got a little bit out. Oh, all over the place. 10. There we go. 10 centimeters in Z, and then we're centered on the X and Y. Okay, perfect. So now we have our water tank set up. We can turn on an electrometer. I like giving it total negative polarity. Some people might not like me for that. You might like doing positive polarity, but you could do either, and you're still going to get, the same references. So now we have our water tank set up. We got our electrometer on. We're kind of ready to collect dose. So let's go make sure we set up our jaws now, and we set up our field size. So we can look at our jaw adjustments here, our Y1, Y2, X1, X2. We see they're all set to 5, and that's going to give us our 10 by 10 field, right? So this is great. So now we want to just, as our output, we're going to collect a charge as our output. So to do that, we're just going to have to prep our beam and then deliver our beam. And so very simply, we'll prep this, and then we'll record these charges, and we'll calculate some ROFs, right? And so as it's prepping, we can kind of see the gear going around, let you know that it's prepping our beam, and then it'll, once it's finished, lets us know. Let's just click beam on. There we go. Now our radiation. We can see our MUs counting up, and then we can also see our charge counting up here. So we'll wait for that to finish, and we'll just record that charge. We got minus 14.939. So I just have a little chart here, minus 14.939, and we can do the nanocoulombs. And so great. And so now we have our reference one, right? We have our reference output, and now to calculate ROFs and compare them, we could do any two, field size configurations and investigate the ROF. And what I'm going to demonstrate now is the jaw that we actually show the jaw exchange effect. And so I'm going to do a 10 by 20 field and a 20 by 10 field, which technically have the same area, but I'm going to show that they create a different ROF because you get different scatter contributions from your jaws, right? Because our jaws are stacked. The X's are closer to the source than the Y's, so they actually produce different scatter, and so they actually have different ROFs for the same area but different field configuration. So first, let's do. I think I'll come over to the console, and let's just change our Y's to 10. So now we have our 10 by 20 field, and then you can see how our field size changed, and now we have that rectangular field size. And so then again, I'm just going to prep my beam and beam on, and then we're going to go record that charge, and then we're going to flip our jaw measurements, get the charge again, and then we can calculate our ROFs, and then I'll just show that even Simac shows that they do calculate a different ROF, and that's how we can show students that these exchanges actually, or these effects actually exist. And then, it really allows them to then see it physically, see that jaw field size changing, understanding which jaws are closer, seeing them calculate it, actually being able to get their hands on it and grasp the concept a lot smoother. So great. So now we got minus 15.34 or 394 for our let's call this 10 by, let's call this the 10 by 20. We'll call the X's are the first. So we got that minus 15.394. And then we'll do our last one. So we'll switch our jaws. We'll put our Y's at 5. We'll put our X's at 10. So then again, we can see our rectangle field is facing the other way. And we can prep this beam. We'll deliver it, collect that last charge, and then we will simply do some calculations and get our ROFs. Prepping the beam again. And then again, just like as this is going, like I kind of mentioned before, we're just doing this for variant 6 MV. Then this extends to both the electric machine and then the 10 and 15 MV energies as well. So, this is where the power of Simac in a program kind of comes in. It allows you to do a demonstration with the students on, say, one energy, one machine, and then assign them to go and investigate it in other areas, and then really get them to understand that phenomenon and come back to you with some answers. So 15.384. And so, yeah, so you can see the charge for the 10 by 20 was 15.394, where the charge for the 20 by 10 was 15.384. So they are not the same for the same field size. And then if we wanted to calculate the ROF, we would just have to, it would be, I'll just do it on my calculator here. So if we were to do our 10 by 20 over our 10 by 10, we get, I've done the calculations here before, so it's 1.029 versus 1.030. So very close, but you can still see that they do actually show a difference in the ROFs, which would be not intuitive, and it would be allow your students to really understand the scatter effects and really why it's important to understand the ROFs can differ with different setups and why it's important to understand your ROF to understand how to get more accurate treatments. So that's great. And that's on our water tank side. So, like I said, if we wanted to go back, then we have the electric machine and you have all of our energies. So we could do that there. And we could do it in a lot more scenarios. And so that's great. So that's on our water tank. So we calculate our ROFs. And then I just wanted to show you again on our normal simulator as well that you can also achieve this. And I'll kind of do it a little bit. I kind of have some things set up for us. So again, I'll come into the same variant. I'll do the 6MV and I'll show you that we can actually get the exact same values back out. And show you that, they're using the same models in the same spot. So yeah. And maybe just as a couple tips as we come into the simulator. So it always runs your last state when you come in, which is we would love some feedback on that. We've done that just so that it's always running, but sometimes it can cause some issues just if you have a strange setup the last time you were running, it will run with that field or that beam you've set up. So just as like a rule of thumb, I always come in and I just always switch the default energies and that'll just kind of reload your default values and make sure you're in a fresh state. So we'll just just switching to the 6MV. Now we're defaulted. I'm just gonna go to my treatment head and I'm just gonna set up our 10 by 10 field and we will get this out. And so then I'll show you what we get calculated here. And so basically we're gonna get a dose rate out in our normal beam run. Really all we're gonna get is a dose rate and then we're gonna get a PDD as well. And so what you could do is you could download this PDD and using your dose rate and the percentage, you could calculate the dose at your 10 centimeters and then compare that and do all the calculations on your own. And I can show you like um, this is what a PDD export looks like. And so if I were to run that beam, which these are the numbers from a 10 by 10 beam, I could go to Simac, I could grab our dose rate, then I could go to our PDD data, find out what my dose percentage was at my depth of 10 centimeters, which I might have to extrapolate a little bit because I don't quite get a 10 centimeter, but it'd be around 70%. And then I could and then I could do the calculation to find the dose at that depth and then do all the calculations. Or I could simply save that state. And so we could call it, ROF 10 by 10, or let's call it ROF 6MV 10 by 10. And I could save that state. And then you see here, there's our TMR test. There we go. ROF 6MV 10 by 10. Oops, I missed the X. Let's run over that. And then what we can do is then we would go to our photon beam, or sorry, our treatment head, and then we can set up our two different beams. We can do the 10 by 20, and then we'll just call this 10 by 20. We'll run this. Wait for our result. Do our 20 by 10. And then what we're just going to do is because we're saving these states, we're going to run them through the water tank. And our water tank actually gives us our D10, which is just, we don't have to calculate it. It's going to show us our D10. We can do the ratios right there. And I'll show you that they're the same as they come out on the water tank. So let's save this. Let's make sure both of our states are there. Perfect. And then we will do our 20 by 10. And we will run this. And then this is just going to be 20 by 10. And again, I mean, in a demonstration like this, it might feel like it's a little bit long, but again, I've run multiple beams all within 20 minutes here, which is just not something that's really achievable on a real machine. So we're still saving lots of time. And, we're all in the comfort of our nice offices here. We don't have to worry about being in the clinic and all of those hassles. So just make sure I save that state. Then we go to our water tank. And then, so basically we can then select those states. So if you did the 10 by 10, then we could call it ROF 6MV 10 by 10. We do a depth dose scan, and you can see here that it's making our field size correct. And then we can run this experiment. We'll run it 3 times, and then we'll go look at our 3 PDDs on the same graph. Grab our D10s, do a little bit of math, get our ROFs, and we'll confirm that they're the same. And then, yep, so then we know our experiment ran. So we'll grab our 10 by 20, and we'll call this 10 by 20. Yes, and it's 10 by 20. Done all this right. So this is great. And this will the running of the experiment. I mean, like again, you can see it's loading here, and then you see that green banner when it actually runs. So we try to make sure that you always know something is going on. And then we will do our, what do we call it? 20 by 10. Oops, 20 by 10. And we'll grab our 20 by 10 and 20 by 10. And let's run the experiment. And then we can go to I'll show you on the review tab as well, just that we do give the relative dose and the absolute dose if you wanted to check that out on a PDD. Just to run. So you do go into here, and so we can look at so here's our dose in centigrade, and then at your depth, so there's your actual absolute, and then there's your relative, where really our photon beam really only shows the relative. So if you want the absolute, you can find that here. And then we just want to go to our compare, and here's our 3 PDDs that we got. And so you can see that, so we came out to 29.176, 30.92, and 30.062. So you can see, I mean, very similar, very, very similar. Oops. What just happened there? And I mean, you can see, like, you could probably just guess that the ratios are very similar. And then I've done the math. I did it yesterday, and it does actually produce the same ratios there. So, I mean, 2 different ways in Simac that you can show it, 2 different exercises you can kind of give to students, one that's a little bit more clinically accurate or closer to what you would see in the clinic using water tanks set up in consoles, and then one more that's a bit more investigative to your profiles and the actual numbers coming out of your dosimetry data. So 2 ways to show it, showing the same thing, getting the same results. And that's pretty much what I wanted to show you guys about relative output factors. So that's what we can do. And like I said, then that extends to any machine and any energy. And just kind of as a closing one, I will also show you the purpose of our labs, because I think this is a really good place to explain this. So we do have all these labs, which our labs are our introduction to Simac. And I think it'll be very clear on how we provide that because we actually have a lab called relative output factors and profiles. And so it really lets you to just look at it without going on the simulator and out doing all that work. Let's get an introduction to the lesson here, understand some theory. We'll play around with some parameters on the simulator, get some different results, but without kind of getting thrown on that full simulator and having to go through the full process. So here, in this lab, we can see the effect of field size on beam profiles and output dose. And all it's getting you to do is change the field size and the depth that we're doing our scan at. And then and then it immediately is updating your crossplane, and then it actually is showing your ROF first field size and your depth dose here. And then what you can do is you can kind of save some of these states and you can display them at the same time and kind of investigate the differences of your different field sizes and depths. And then it takes you through a set of questions. So this one, set the field size to 10 centimeters and the depth to 1.6. So let's just do that quick. 1.6. What is the relative output factor? Save this state. So then we come out to relative output factor. Boom. Look at that. It's 1. And that makes a lot of sense, right? Because we're at our Dmax in a field size of 10 by 10. That's what ROF1 usually is. And so then it shows you to save that state. Boom. So we save that state. Now display the same state from question 1, right? So it's really taking you through this theory. And so this is how our entire platform works together, right? You get that initial lesson with the instructor. Let's go over one energy. Let's do it a couple different ways. Now go do your exercise. Go do it with different energies. And now you can access that platform anytime, any place, and really, really, not have to worry about real machine time or breaking machines or the stress of the clinic. So this is really what we're trying to provide for people, and we really believe that Simac can help people's day-to-day Linacs jobs just easier. Just being able to investigate beams before you go into the machine, just being able to kind of research some different configurations that you're looking at, and you can do it at any time and any device. There we go. We're coming up on the half an hour. I know I've been just yapping a lot, so I hope this was useful. And I'll hang around for a couple minutes if anyone wants to chat about anything, any questions or concerns or issues they're running into on the platform, anything they would love to see on the platform. Happy to answer or discuss.
Yeah, there haven't been any questions here posted. So if anybody has any questions now, please feel free to ask. But I think it was really good for you, Quinn, to point out that you can cross-reference things. The way you're doing it, go back to that lesson, take a look, kind of walks you through it. It gives you, in case you forgot what you were doing there, it shows you how to do it, and it gives you the theory behind it. So that's really
and this
great.
is what students and people that aren't confident with these things, these are the tools that just empower them to kind of take it on themselves. Thanks, Amit. I appreciate it. And then of course we're gonna get the recording up for you guys. I'll email it to you. We'll put it on YouTube. And so if you ever want to come back to it. Oh, and just I will show you guys in that student resource portal again. That's where the recordings are gonna go up. And that's where the registration link always is. If you just come here, the registration link is always up there. And then you can see there's the last 4 sessions we did. And then the new session will be up here in the next couple days. But like I said, we're not going to do a webinar in January just because first week of January, people are usually busy coming back from holidays, but we'll get back to them again in February. And I did remember we did have one question on the sorry, not November, December. Just on the registration, you guys can always request demos, and then I'll try to cover them during the session if you guys don't want to join or if it's at the wrong time. And they were just asked about a dose interlocks on Simac, and we don't have it yet, but it's coming. And so we're developing it to our next version of our simulator, and we'll have some interlocks with our servo wing systems and things like that. We don't quite have it yet, but I will say we do have a full chapter already in our advanced course in our advanced course textbook. So it's something that we definitely cover in our teaching and are on top of getting it in our simulator. We don't quite have it yet. I'll make sure that if we do, I will get it into a webinar demonstration. Yeah, did someone have their hand up there? Thought I saw it for a quick second.
I don't see anything.
Okay.
No questions in the chat. So
perfect. Okay.
Thank you very much, Quinn.
Yeah, thanks, Emilio. Have a great day. We'll talk to you later.
You too, and you all.
Thank you.
Yep. Bye, everyone.
Yeah, bye. And then I guess, and then I'll just say, happy holidays to everybody. This is our last one of the year, and thanks for supporting Linacs. And if anyone has any questions about training, you want to see the simulator, get one-on-one demos, email learning@linacs.ca, and we will help.
Just last question, Quinn. Is there a possibility for the future in 2026, for example, to have the possibility to have at our disposal to fine-tune a profile I mean, starting from the data in our Linac, for example, a variant or an Electa related
Yep.
to accelerator guide, a klystron, and so on. Is there a possibility to tune, from some point of view, the profiles that we can see in Linux?
Yes, that's where we're really trying to go with that new simulator is like introduce that servo system. So we will have like they'll be automatic, but then if you went into manual, you'll have some very, very fine adjustments for some beam matching and beam tuning. And then like
Exactly.
eventually, yeah, and then eventually what we really want the simulator to be eventually, right, is a place where that it really matches your machine model, and then you come in and your machine state is malfunctioning, then you can look at your simulator and say, okay, where were we yesterday and where are we now, and then how can we get our beam back to where it was?
Exactly. This could be very interesting.
Yes,
And just
that
in order
is.
to understand what happens in a machine in real time, probably in real time, but
Yes,
for example, from the point of view of TPS commissioning, it will be very, very, very interesting.
exactly. Yes. And so that is our that's 2026 Linax goals. That's where we are in 2026. So stay tuned and we'll keep you updated on that.
Okay, thank you very much.
Yeah, no problem. Okay, guys, I'm going to end it there. So, everybody, thank you again for joining, and hopefully, we'll see you again soon.
Bye.
Bye.
Have a nice weekend.
Yeah, you too.
You
See you
too.
guys.
Bye now.
Bye. What's happened?